Hello everyone, this is Ming. So today let's continue our Panda exercises. Okay, let's look at where we were yesterday. So I'm still referring to this GitHub repo from Grip Samora, where he provided a bunch of Pandas exercises, which is great. Um, so yesterday we were looking into the grouping, apply. So today let's continue merge and stats. Okay. So because I already done cloned this repo previously, I just need to see go to there. Um, we'll go to pandas exercises. Okay. All right. Delete the notebook. Okay, so let's look at the merge. There are 3 exercises. Let's look at the first one. You set up the kernel. All right. So import necessary libraries. Let's do import pandas as pd. Import the files, first data sets. Okay. Cars 1. So I'll just directly do this. Equal to pandas pd with csv. Okay. So cars 2 equal to pd with csv. Sorry about the noise. It's my buddy Rocky. He's drinking water. He's a boxer, so later when we get a chance, I'll ask him to say hello to everybody. All right, here we imported 2 data sets. So oops, it seems our first data has some unnamed blank fixed car. Okay, so let's check it out. Cars 1 at. So we probably need a separate cells for this. Alright, let's get it out and then insert the 2 and car 1 head. So let's check car 2 head. Cars 2 head. Okay. Unnamed. Blank columns. So let's look at the scroll. Okay, it only had this, so probably what we can do is cars 1 drop. So we just provide the column name. Let's see if this works. I think it's gonna work. 10, 11, 13. Alright, we need provide access at, I guess. Let's check. Yeah, access equal to 1. Perfect. So it's 1. Call and draw origin 4. Interesting. Info. Yeah, okay, looks good. So we just need to reassign this to. Okay. So what is the number of observations in each data set? So let's do this. So this is a syntax, I think, supported from Python 3.5 plus. So where you can do the car1 data as we use curly bracket to pass in variable, and it will evaluate the variable within the string. So this will be how many observations? Just cars 1, shape 0 observations. So previously we have to do the for example like this data has we do this. Let me fix this actual comma. And then let's get it back observations. Then previously we had to format. Format here we pass in cars 1, cars 2, shape 0. Most of this works. Oops. Yes. Okay, cool. And also we can do just name it. So here we can do num equal to. Okay. Join car1 and car2 into a single data frame. Okay, join them into a single data frame. So I guess it's concatenate. We need a concatenation. So concatenation, let me do a pandas concat. We need concatenate by by rows, along rows. So if you use R before, it's similar as like R bind. So you bind by row. So first data set, second data sets, you put them together. Let me find if I can get a nice zero here, which will be more intuitive. Yeah, here it is. Well, let me find, yeah, this one. Sorry of the slow internet. Okay, we'll put them all together. Okay, so we'll just use PD concatenate. Let's see. Cars is equal to PD concat, right? So we'll provide the list of the objects, which is list of data frames. Cars 1, cars 2, and x equal to 0. Okay, let's check cars. Cars. Oops. Okay, so this is not what we want. It's a let me see. Is it true? Yeah, it looks like it is. Yeah, sorry about that. It is what we want. However, so just look at index. It was index was off. So we need to fix index. So let's check why I say it's off. So if we do index, let me make it a to list. You can see it's from 0 all the way to 197 and then start from 0 again. Okay, so this is probably not what we want. Right, so let's look at the join axis, no, join alter. Let's do ignore index. Let's ignore index true. See what it returns. Okay, now it actually ignored the original index and redo the index, which is what I want. Okay, looks good. So, oops, there's a column missing called owners. Create a random number series from. Okay, yeah. Let's see the shape. Why it's missing? Okay, so I thought initially I thought it was like one data frame has the owner column, the other one is not, so it says owner, so it automatically ignore it. Looks like it's not the case. So it's just this one asks us to create a random number series as the owners column. So we can do cars owners is equal to. So here what we can do is random. And so let's look at the. I don't have that, so let me import it. NumPy. It's np. Okay. Now I have the NumPy library works. But it will give it red. Okay, so that's dimension, and the rand gives me um, like random values using the given shape, um, just a random value from 0 to 1. So what we can do is using a formula that's called, let me turn this one into, okay, so let's see, um, mu is a random variable, from distribution, unit 0 and 1. Okay. So let's see. Oh, okay, cool. Let's call this U. This is uniform distribution. And our targeted distribution is uniform. However, it's from, this is a minimal, right? So what we can do is let's see, let's just call it R is equal to, let me use double dollar sign, which makes it centered in the line, and each one takes one line. So we start from here, and then we just need um, use mu times minus. So I probably do subtraction here, which gives me 5/8. Yeah, okay. Okay. So by doing this, we can do it's equal to 1 plus times. So we want to give it a shape, and then we'll do broadcasting. So shape, let's make it a column vector. So that gives me how many we want the rows. Maybe 398. However, I want to make it dynamic. So we cars shape 0 and 1. Okay. Oh, okay. So I don't need a tube around it. I just directly pass it in. All right. So let's check cars again. Oh, we did a step 8 already. Okay, we did the two together. All right. Let me just copy paste here, and just just check it. Nice. Okay. So we need integer. Random number. Create a random number series as called owners. So we probably need integer. Okay, so let me just Google it. NumPy generate random integer. Rand int. Okay, this is the function we probably need to use. Rand int takes low and high and the size. Okay, that's much easier. Okay, so what do we need to do? Instead of this, we just do np random int, give the low, which is 1500 and 7300, and the size is just cars shape 0. This can be running. This looks like a more reasonable as a unique IDs for owners. All right, now let's check the solution. The magic moment. Let's see. Continue without kernel. Yeah, okay. It using NumPy as well. Put in. Okay. Oops. Okay, they use the lock function, like location, with the column names, column index to select it. I just using drop, so which achieve the same here, which achieve the same effect. Okay, car shape, referring to car shape. Okay, cool. So, oh, there's another way to do this. Just append. Let's check that out. What append does. Pandas append. Come on, internet. Okay, so append the rows of other to end of color. Okay, it append a row like append the additional data frame as rows. Okay, so this is something I didn't know before. I always use concat because using concat you can control its append as row or append as columns. So this probably will give me error if I append by columns because two data frame has different lengths. So let's check it out. Oh no, it's not giving me an error. However, it's doing an auto join. Okay, so let's look at what it does. Yeah, it does something like an auto join. So for the rows, in the first data frame, um, it's just filling a bunch of arrays. Okay, that's good to know. Um, and it's joined by index. Let's check the piece of index object, especially used to start from key sequence. Hierarchy index use passkey as auto. Yeah, so here what I think is if we didn't provide any keys where it's used to concat or combine them, it will use keys automatically. It will use index automatically to match them. So one way to check this is let's do a little experiment, very quick one. What I'm gonna do is copy this. I'm gonna concatenate those two data frames along second dimension with axis equal to 1, which indicates the second dimension. And I'm going to use the inner join, right? Join inner, just to test my hypothesis. Inner. Okay, so let's look at it. Yeah, it is using this one. It is like up to 198 rows. However, we still need to verify one more thing, which is it using index to join them together. So what we can do is print cars, allocate, raster, and we do. So this cars 1. Let's do cars 2. Okay. 29, 4, 90, 9, 2, and Volkswagen rabbits, and then 32. Oh, we need a. So this one has 200, so we need this one. Yeah, because when you combine, it will only take rows for within data frame cars 2 only up to row 198. So which is from the end is -3. Okay. Yeah, cool. So I think this verifies my hypothesis. Right. Let's continue. Oh, here it is specified d type equal to, I think L stands for long integer. Okay, I don't have it, but I don't think it's matter. Okay, this is just printed out. All right. I think takeaway for me on this one is we can use append, specifically append method from Pandas is actually append by row based on its document. And concatenate is a little bit more advanced and more versatile, more robust because you can along access, first access, second access, or even higher dimension, and you can control it outer join or inter join, and also actually you can control the keys on which it matches the rows together. By default, I think using the index, raw index to match the rows of two different data frames. Cool. All right. One down, two more to go. Fictions names. All right, let's read some fictions. Secernals. Okay. Special thanks to Chris Albon. Yeah, I think I showed his website in my first video. I used his flashcards before, just refresh my knowledge, which is pretty good. Check it out. In order to understand it, go here. So let's see what it is. Oh, SQL joins. Okay, so I think I can just directly go for it. Okay. Import necessary libraries. Import pandas as PD. Import new SMP. Okay. Step 2. Create 3 data frames based on the following raw data. Okay, so if I use raw data, why I need to... Oh, never mind. I saw this... it's not like the last one. I need to download the data set. Data 1 equal to PD data frame. So we can directly pass it in. Data 2 equal to PD data frame raw data. So I think in Jupyter Notebook you can use tab, yeah, to autocomplete. But I'm intentionally avoid it just to practice my skills. Okay. Okay, so let me check. Data 1, okay. Data 2 looks good. Data 3, okay, looks good. So join the 2 data frame along rows and assign all data. Join the 2 data frame. Okay, so I think join the first 2 data frames. Okay, so which is perfect. We can use the our access before. So all data equal to data 1 append data 2. Ooh, data. Yeah, looks nice. Oh, see, the index has some problem. Let's see if it has similar index. True. Just copy this. So what I do? Undo. I think I did. Okay, here it is. I accidentally hit D twice, so it deleted my cell. Index equal to false. Oh, equal to true. Okay, great. So join the 2 data frames along columns and assign to all data column. Join the rows along columns. Okay, wait. I think my understanding of step 4 is wrong. Okay, so let's check it again. Like data 1, let's look at the data. B to insert below. Data 2, data 3. 1, 2, 3, 4, 5. 4. Subject ID. Subject ID. Test ID. Join the. Okay. Let me do it first. Join the 2 data frames. It has 3 data frames, right? Okay, I still think this way is correct to integrate. Join the 2 different columns and assign to call printers. Okay. Along columns. We join them along columns. So I guess it's all data. Let me look at this again. It's open the rows. Okay. So I might need to use concat. So pd concat. Data one, and data two, and here x is equal to 1. And let's check the result. Yeah, I guess this is what my guess. This is what it asked for. But let's check it with the solution later. So let's print the data 3. So merge all data and the data 3 along the subject ID column. Okay. So what we do is pd merge, and I use SQL more than this one. So okay, so let's follow the syntax. Merge all data. First one, data 3. What comes next? How inner. Okay. By default it's inner. Well, okay, inner. And let's see on equal to which key, which is join on in equivalent in SQL. So we join on subject ID. Okay. Cool. So merge only the data that has the subject ID on both data 1 and data 2. So merge the data sets are the same. Okay. So I guess what it does is pd merge data 1, data 2, and on subject ID. Okay, it gives me the result, which is intersection. Join, I'm doing inner join. By default, it's doing inner join, and it will return me that the records subject ID showed on both in both data frames, because by default it's doing inner. Okay, so here by default it's doing the suffix x and y. We can customize this. Oops, there it goes. Let me copy this one. I'll do this left and the right. So this will be added when the column name from two data frame are the same. So it will add this try to distinguish it. Cool. Merge all values in data 1, data 2 with matching record from both sides where available. So this looks like an outer join. So let's do merge data 2 and how. Let's give it outer. Yeah. Did I spell it wrong? Let me check that. Oh, yes. Sorry about my spelling. Okay, it will do an auto join and return 9 if it cannot match. Okay, so let's check the results. One, two, three. This time it is concat. Okay, I use append, which learned from previous one. I guess both is okay. So the solution ignore index, which I think which might cause potential problems. Always, in my practice, I just try to avoid any potential problems as possible, as much as possible. Okay, so yeah, this looks like it's concat, but along axis one. Um, and data three, yeah, let's data three, and the merge on. Okay, cool. This is doing a drawing, and then let's do this is inner. It's ready here, but default value is inner, so that's why I didn't put it out. This is the outer join. This is the outer join too. Okay, good. All right, two down, one to go. Okay, housing market. Housing markets. All right. Okay, housing market introduced in time create our own data set. This time we'll create our own data set with fictional numbers to describe our housing market. As we are going to create a random data, don't try to reason numbers, all right? I'll hold my opinion. That should be first random number, the first a random number from 1 to 4. Create 3 different series, each of length 100 as follow. Okay, so what we can do is one np random run the int as we learned before, right? So size. Let's see how we special size. Int or two of int. Okay, so size a dual column vector, which is 101. Second random number from 1 to 3. Okay, so 1, 2, 3. Third one, bitch. Okay. Let's create a data frame by joining the series by column. Joining the series by column. I guess it's just putting all them together. So what we're gonna do here is just df equal to pd data frame. So here we're gonna pass in a one, that's1, that's2, that's2, that's3, 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 that's3. You must pass an index. If using all scalar value, you must pass an index. Let me try this. The dimensions might cause for complaints because this is an ND array, but then we need a 1D array here. Yes, that's array then because I was using 10.1. It's a column vector, but it's 2D array. To create a data frame here in this way, you need to pass in a 1D array. Okay, so let's check the F. There it is. Looks good. Change the name of columns. Well, how do we do it? Just columns equal to array of text, array of words, bedrooms, pass, price, square meter. Create a one column data frame with the value of 3 theories and assign it to big column. Okay. Yes, what we're gonna do is data frame. We need to concatenate those 3 leads together, right? So we still can use a dictionary. We just column 1 as the column name. With various traces assigned to big column. You know what? I'm probably a little bit lazy, so let me try this. Try this method. I'm going to using NumPy. Yes, I have NumPy here. So for column one, and what I'm gonna assign is df values, which gives me 100 by 3 column. I just do reshape, or I just do flatten. Flight. Okay. So let's check this. So let's see what the values flat gives us. I think it gives us a flatter. Okay, no, flat. So first let's check the values. Yeah, it's like this, right? So what do we want to do? Let's reshape to check reshape takes in shape as can we put an integer in the shape? Okay. So I'm gonna try anyways. So df shape 0 times df shape 1. Ooh. Oh, 300. Okay, cool. This is probably what we need. Do you hear? Yep, which is our big column. I think I'm cheating here. This might not be exactly what the question asked for. But anyways, notice there might be a problem because it reshaped by rows, right? What we want, probably what we want to do is put the column 1 all together and then column 2 and then column 3, like in that way. Okay, so if that's the case, what I need to do is, in Python, there's one S1 to, if you add two lists together, which means it's just an extended list, concatenated list together in Python using primitive data type, the list data type of Python native list. So let's say S1, so this is a NumPy array. So what we do is two list. So this give me a list. I'm gonna plus S2 to list. Yeah, this is long. So I'm gonna plot S3 to list. Yeah, so let me check the length of this final list. 300. This is probably what it needs here. Yeah, now see right now this column is the S1, S2, and then S3. Cool. So yeah, here's a very convenient way to concatenate a Python native list. So if you do S1 plus S2 plus S3, so it's not because it will do element-wise summation. So let's check the results. Yeah, it will return only 100 and put all the number together. So notice the difference. Cool. Oops, it seems it's going only until index 99. Is it true? I didn't say it only goes index 99. Okay, now I know. I might interpret this problem wrong. What it asked me to do? Using concat. Okay. So what it probably asked me to do is series PD SERES. I think this is probably what it asked me to do. Instead of directly NumPy, we need to use PD series. So hey guys, like I think one thing we need to notice is in our real life, we can use whatever method as long as we know what we want to achieve, which means we know how we want to combine this data together. But here I'm redoing this, or I'm guessing what the asking question asking me to do is purely from the perspective that I want to practice my skills. It is especially within this context, because this context is a merge, right? Probably you need to use merge concat. So that's why I'm spending extra time here. So let me try this. So if this case we need a PD concat, and we put S1, S2, S3, axis. Select that if oh, it's by row, by column is like this. Okay, that's good. And then okay, change it like this. Big column. Big column is PD concat. Still S1, S2, S3, and axis by row. Big column. Yep. Okay. What it looks like index from 99. Yeah. So this is the problem. So what we can do is reset. It's not true because we can big column index to list. Let's see, it's not only up to 99. It's just a repeat. Okay. So what we can do is big column reset index. In place equal to true and big column. Okay, so this is what I drop equal to true, and if you want in place equal to true. Yeah, cool. Check the solution. Solutions. Okay. Yeah, now you're right. Yeah. Okay. Yeah, it is concat. And then rename column. Okay, this is another way if you want really specific on the first column name at this, second column name at this. However, I know this is how it's layout 0, 1, 2. So I don't think it's necessary, but it's good practice. Just prevent if there's any uncertainty that somehow the column orders, the order of the columns in the original data frame got changed before you assign. So using this mapping dictionary, so use dictionaries which serves as a mapping function is safer. So concatenate them together. Concatenate to frame. So if you use a to frame. Yeah. So if I'm not using to frame, let's see what's in. Oh, series. Okay. So we can do to frame. Cool. So yeah, this is something. Actually, I did it wrong. I just returned out series, but it asked for a data frame. Cool. Sequence columns. Drop inputs true. Yep. Okay. If we run this again, yeah, it will return the frame. Okay, cool. Nice. Oh, let me save it. Okay, I think we'll finish on number 5. Let's do stats. only 2 exercises. Okay, let's check the first one. Set kernel. Okay. Oops, import Pandas xpd, import numpy xmp. So it's it's a CSS. So baby names equal to pd read csv. To the first one, baby names add 10. Cool. Delete the column and name. Okay. So we do baby names drop. Copy it. So I just equal to 1. Let's on it. So it dropped. So baby and reread it. Something wrong. Into. Okay, finished. I was take too long. Okay, now it's okay. So is there more male or female in the data set? Gender? Okay, so what we can do is utilize what we learned yesterday or from last session. So baby names, group by gender, and we choose size. Cool, see? We have more females. Group the dataset by name and assign to names. Names equal to baby names group by name. How many different names exist in the data sets? Line names. Oh, 17,632. What's the name of the most frequent? So what we can do is baby names name unique value count values count. Oh. So now unique. Directly we can use value counts. Yep, and it's already sorted. So just to be safe, we can do ascending. Go to ascending to false. Okay. Relay is the most occurrent name. How many different names have the least occurrence? Least occurrence. Okay, so we just do this one. Do it again. True. And let's have 10. Okay, so we might need more. So let's assign it to our data frame. Pen. This one. So type is equal to 1. We just repeat that sum. 3,682 names only occur once. What's a median name occurrence? Okay, median name occurrence. So we just do this one. Median. Median. 8. Okay, 8. So let's look at temp media. So we need the temp equal to temp media. So we need to select temp equal to media. Okay, those are the names. To list. Those are the names. Media name. What's a media name occurrence? Okay, media name occurrence. We just need to get the media names. Right? What is the standard deviation of the names? Okay, temp. Yeah. Get a summary with a min max standard and query. Quantels. There it is. Okay, so let's check the solution. Names unknown. Deliver minimum ID. Oh, I didn't do the ID. I forgot. Drop ID. Can I really do it? It's my way. It won't affect the later exercises. Let's look at, yeah, it's the value counts. Step 7. Oh, guys, okay. I made a big mistake because I totally ignored the count here. All right, I see. Names equal to group file name dot sum name dot head print name dot h. Okay. Group this by name group the database by name and assigned names. Year. You don't want to sum year code. Okay, so what we need to do is actually names, maybe names. So I'm gonna do it in my way. So I just needed to select the name and count because it's really need to by name names sort and by false. Yeah, Jacob. Okay, so this is how I solve this one. So length names comment and x. So then it's just a Jacob because let's just do sort values I count. Sun equal to false, and hat 1. How many different names of the latest occurrence? So what I can do is just see. So I'm gonna do this. How many names have least occurrence? Least occurrence. What's least occurrence? Least occurrence is equal to 5, right? So what we can do is names count equal to 5. So yeah, so 5. And what's a media? So just names media. And the names derivation. And the names, let's compare the result. What's the median of occurrence? 49. Okay. That's the derivation. Yeah, same. Describe. Okay, cool. Yeah. So let's learn from this exercise. Actually, it happened a lot. I made a similar mistake before. It actually, in order to do the stats, you don't need only look at this column. It's not enough by just looking at this column. Usually, it has another column like same as counts or quantities if it's order table. So pay attention. Cool. All right, one to go. Hey, Rocky, whining. Set kernel. Alrighty. The data has been modified to contain some missing values identified by NA. Using data should make the exercise easier, in particular for the bonus questions. Bonus question. I like it. You should be able to perform all these operations without using for loop or other looping constant. The data in one data has following format. Okay, looks like this. So it's probably separated by space, I guess. The first 3 columns are year, month and day. The remaining 12 columns are average wind speed. Okay, to 12 locations. Month and day, that's here. What tab? Yeah, let's try. Import Pandas as PD. Import new pi as MP. Yes. Assign to variable called data and PD with CSV. Step separated on B and T. Okay, let's check out the okay, it's not. Let's go here and check it out. Description. Oops. Okay, in this case, I'm gonna use one of my favorite IDE. Okay, let's see. This query will speed the data will analyze the details how each line comes in day. Not very useful information. That's Google. I'm just gonna Google to see if I can find a similar analysis. No, it's not what I'm looking for. Okay. Let me try read the table. See if this works. No, okay. I give up on this one. Let's check the first one to see how the solution tackle the first problem, how to read the data. Oh, SEP S plus. Okay, no, I never used this before, so I definitely need to look it up. What's S plus stand for? And parse dates equal to. Oh, that's cool. So let me do a quick search on equal to x plus. What's this for? Those different separators. Different separators. What's this stands for? Regex, uppercase, lowercase, lowercase. Interesting. I guess it's some character like space plus, like more than one space. Okay. Yeah, I guess that's a reason. And oh, okay. See, here's a problem. Here's has some problem. It passes 1961 to 2061. All right. So what we can do? Um, do we really have this create a function to fix it and apply it? Okay. So what we can do is data first column. Probably we can use a lambda function, as we learned the other day. Lambda x. Okay, so it's gonna feed in element by element. What it does is let's before we do this, let's check data. What's the type of this? What's this type? I think something time related. Let me do a quick Google search. Okay. So this is a relationship. Data times 64 is a general type, while M8 is a specific D type. Okay, it's fine. So if this is case, we need to make if So what we can do is calculate the time delta. So what the way I can write it, if what I can do is x year. So let me see if I can use it. 0 time step. And I can see if I can have a year. Okay, so if year is bigger than, let's see what's right now, 2020, then I'm gonna assign to, I'm gonna x year equal to x year minus 1000. Cool. Else just return x. Let's see. Let me look here. Time step. Hands off. Set year. Let me see if I can update. Manipulate time date. Creating date object. So it's a time step. Time step. Person. Time step. Delta. So, set here. Okay, so I'm a little bit confused here. So I'm gonna do Pandas Python date. So, 3.8. Let's create a date time. Python create date time. Okay, so I'm gonna use this method. Okay, I'm gonna convert everything in date time. So what I'm gonna do is import date time, and if x year is bigger than this, I'm gonna do a return a date time x dot year minus 1000 and x months. So x months date day. Cool. So I'm gonna x months x day. Otherwise, I'm gonna do yeah. It's gonna do the trick. I subtracted too much. So I just need to subtract 100. Yep, this looks good. All right. I think this is definitely, there is a much more simplified way to do it. At least I get the job done now. Set the red date as index. Pay attention to the date type. It should be date type. Okay, so now let me see this. Date type. Okay, so as type. So we input. Okay. So do a type. Check it again. Okay. So it's not in place. We need to assign it. Mm-hmm. Okay. What is data? B type. Oh, okay. So I guess probably if we don't do this step, let me read the data again. We do this one and check it. First column. Yeah, cool. Just some, I think because M8 is a specific time of the daytime, daytime 64. If you do date type, then it will show you this. However, indeed, I think it's okay. If we just directly plug, print this out, it shows daytime 64. That's good. So then we need to do is date set index. I think we used this before. So here month day drop equal to true, and let's print the date data data head. Oops. No. Set index drop equal to true keys do this. Oh, we need to in place equal to true. Cool. Compute how many values are missing for each location over entire period. So this is different location. How many values? Okay, so what we can do is data is NA sum. Cool. Here's the missing values. Compute how many non-missing values are there in total. Let's just use the entire row column minus this one. So let me see if there's a Panda way of doing this. How many non-missing data? Maybe keep in. Keyword some Pandas some keep in. Oh, well, okay. Keep dim is for NumPy, not for Panda. Seems cool. So how many non-missing values are there in total? Oh, in total. Okay. So what I can do is data shape, right? This is giving me a total number. How about length? Size. Yeah. Let me verify. Neural comes data shape 1. Yep. Size minus Then I can do one more sum. Yes. Cool, this is the number of values not missing. Calculate the mean wind speeds of the wind speed over all location and all time. A single number. So data mean, I think it's a x is 9, 5 is 9. Skip on. So we need a skip array. Cool. So by default it is. Then I mean one more time. Cool. Create a data frame called the location stat, loc stats, and calculate the mean, max, wind speed, standard deviation of the wind speed at each location over all the days. Okay, so we do data, AGG, mean, max, mean, mean, check it out. Cool. Let's see if we can ignore array. Skip array, cool. Create a data frame called the day stat. And calculate the mean value standard deviation of the wind crossover at each day. So what we can do is similarly just transpose it. HG day stats. Come on, a bit slow. Cool. Or I can do by AGG by axis. Yeah. That's AGG. Yeah, it has axis here. I think that might be the better way. Let's equal to 1. Okay. Hope you guys are still hanging there, almost there. Find the average. Okay, cool. Yeah, this is what we want. Cool. Find the average ratio in January for each location. Trait generated January. Okay, so this what we can do is this. However, we do need a data index to let me run some experiments. Date months equal to 1. So we need this. Cool, this is January. Downsample the record to a yearly frequency for each location. Downsample the record to a yearly frequency for each. To a yearly frequency. Okay, so it's just downsample the record to months frequency. Okay, I think I can't think of an advanced way, but what we can do is year. So let me try group by data index here. Some. Cool. for me. This is average wind speed, right? So what we can do is mouse. Okay, so this is the week. Cool. Calculate mean, max, and linear speed and standard deviation of the initial across all locations for each week, assuming the first weeks. Give me a second. For the first weeks. Okay. So what I'm going to do is ABG. Max. Okay. Cool. I'm not quite understand the second half of these questions. So let's check the result. Okay. Oh, I opened it earlier, but never mind. Let's just compare it. Fixed century. Oh, okay. They use the similar method as I do. All right, that's good. Seven x. Okay. No some, yes. No some. Oh, okay. So I'm calculating total size. So to use not null. Okay, so this is something new. I don't know. So let me test to see if that gives me the same answer. Yeah. Okay. So this is right. Okay, we use this, but I think mine is better. Describe percentiles. Okay, so let me mean 12 10 point. Okay, so that's correct. Yeah, I think my method is better. Let me add STB. Yeah, I think my method is better. It's more aggregate. Cool. And 12 to period. Index to period A. Okay, we are achieving the same. Okay, same way. Monster figures. Okay, so here is different. I'm just doing monthly, but I guess it's asked for. It asked for is 2 period. What's different is keep the year information here as well. See, and I think this one is same thing. Period and week. Cool. This is different. Check if the result. Okay, the result returns. I think it should be the same. Yes. Yeah. Cool. Let's look at the last one. A little bit confused. Weekly, or we sample weekly average mean. Each week for first 52 weeks. Okay. Instead of group by, we need a weekly data read sample w agg min x min cp weekly index from 1 to 52, or just like this, and everything. Yeah. Resample. Okay, so it looks like it's by the. So what's different? Oh, probably. Weekly frequency downsample reason. Assume that the first week starts at 1961 for the first week. Okay, so this is a difference. This one use resample. I think we encountered resample yesterday. So revisit. Just read the document one more time. For time series data, convenient method for frequency conversion and the resampling of time. The object must have a data index or pass the value. Okay. Cool. Resample each week. So what's really interesting is, see the index here to period. It use this resampled week. We treat the first week as general tool. Okay. This is a difference. This one equal to this one. Okay. Yeah. All right, guys. I think takeaway here is using the data like the index, using the methods on top of data like the index to quickly convert the frequency of data into year, month, week, and also you can resample it using the resample method. Cool. All right, I guess this is it for today. Thank you very much, and see you tomorrow. Bye.